Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 7, unit number 8, functions and graphs. In this video lecture, we will discuss the exercise question of 8.1. Exercise 8.1. This is exercise 8.1. Exercise 8.1 contain 7 questions. And in question 1 we have 4 parts, in question 2 we have 2 parts, and so on. So we will discuss these questions one by one in detail. So coming towards the first question, in first question you see that a function f of x is equal to x square plus x minus 1 is given. This is your given function. You see clearly this is a quadratic function. Now you need to find out the images of -2, 0, 2 and 5. So these are your inputs, and you see that these inputs from the set of real numbers. You already know from the theory that we discussed in previous video lecture that the domain of the quadratic functions are set of real numbers. So these values from the set of real numbers. So when you are finding the images of these values, so means you need to put these values in the function, and the value which comes in the output when this function x square plus 1 minus 1 operates on these values one by one, so you will get the image of their input. So these inputs are domains because they from the set of real numbers, and set of real numbers is the domain of this function. So one by one we will discuss these parts. Okay, so part number 1 of this question is the given function is f of x is equal to question number 1, the given function is f of x is equal to x square plus x minus 1. This is my given function. In part number 1, find the images of -2, 0, 2, 5. Mean this part 1, this question means that when you plug -2 in this function, the value that you get is actually the image of this function, the image of -2 under this function. So you just need to plug these values one by one in place of x in this function, and the value that you get after calculating this expression by putting these values will be the image of that value under this function. So this is so easy question. In solution you clearly see that for x is equal to -2, let's say this is equation 1, put x is equal to -2 in equation 1. So equation 1 will become, when you replace x by -2, so this is -2 whole square plus -2 minus 1. So f of -2 is actually the image of -2 under this function f. From this calculation you will get a value. So this is 4, this is -2 minus 1, so this is 4 minus 3, you will get plus 1. So the image of -2 is 1 under the function f defined by f of x is equal to x square plus x minus 1. So this 1 is the image of this -2 under the given function f of x is equal to x square plus x minus 1. Similarly, you need to calculate the image of 0 by putting x equal to 0, and calculate similarly putting 2 to find the image of 2 under this function. Then 5, just put x is equal to 5 in this and then calculate. So these 3 is the assignment for you people. Okay, this is part number 1. Now moving towards the part number 2. In part number 2, the title of the question is the given function is question 1. In question 1, the given function is f of x is equal to x square plus x minus 1. In part 2, if f of x is equal to 5, you need to calculate the value of x. Then find the value of x. This is the question. So you see that let's say in solution given is f of x is equal to x square plus x minus 1. This is your given, and this is a condition given in part 2 that f of x is equal to 5. If f of x is equal to 5, this is also given. So then you need to find, the requirement of this question is to calculate the value of x. So let's say this is equation number 1, and let's say this is equation number 2. So you clearly see that the left hand side of both the equations are equal, f of x, f of x. So from these two equations we can write, from 1 and 2 we can write x square plus x minus 1 equal to 5. Because the left hand sides are equal, so you can write the right hand sides are equal. So now this is a quadratic equation. X square, I'm converting it into the standard form. So when I shift 5 on the left hand side, so 1 minus 5 mean minus 6 equal to 0. Now the coefficient of x square is 1, the coefficient of x is 1, and the constant term is minus 6. So when I multiply this 1 with the constant term, mean the coefficient of the x square with constant term, so you will get minus 6. So then you need to split this one, which is the coefficient of x, into such two parts that from their product you get minus 6, and from the addition you get the coefficient of x, which is 1. So this is plus 3 minus 2. When you add 3 with minus 2 you will get 1, and when you multiply 3 with minus 2, so you will get minus 6. So I am solving this quadratic equation by factorization, extreme means. You can also say that by factorization. So this is x square plus 3x minus 2x. From 3x minus 2x you will get 1x, but from their multiplication you get the multiplication of the first term and the last term, which is the x square and minus 6. So taking common x from the first two terms, so x plus 3 will remain, and here you will take common minus 2, so x plus 3 equal to 0. Now x plus 3 is again common, so x plus 3 is taken common, and the remaining is x minus 2 equal to 0. Remember here, whenever the product of two numbers or two variables are equal to 0, or two factors are equal to 0, so one of them at least must be 0. So here you see that the product of x plus 3 and x minus 2 is 0. So it means that at least one of them must be 0, at least. So thus from this we can write x plus 3 equal to 0 or x minus 2 equal to 0. So this implies that shift this 3 on the right, so that will become minus 3. This is one value of x, and shift this x minus 2 on the right, so this become plus 2. So x is equal to 2 and x is equal to minus 3 are the values of x. Now why you get two values? Because if you see to the given function, that is quadratic. So when you compare the given quadratic function with the given condition in part 2, that if f of x is equal to 5, so you get a quadratic equation. So this is a quadratic equation. The quadratic equation means the highest power of the variable is 2, degree is 2. So remember, according to the fundamental theorem of algebra, the number of the roots, the number of the solutions, the number of the values of the variables are equal to the degree of the given equation. So here degree is 2, so that's why you get two values. This is part number 2. Now moving towards part 3 of question 1 and part 4 of question 1. Okay, part 3 of question 1. In question 1, the given function is x square plus x minus 1. In part 3, you need to calculate f of x plus 1. So it is so simple, just replace this x by x plus 1. So here is x, so that x will become x plus 1 whole square, this x will become x plus 1, and minus 1 is as it is. Mean the argument here is x and this function is given. You need to calculate the function, the same function f, but you just need to replace the argument by x plus 1. So in solution, f of x plus 1 will be, you see that if there is x, so there is a square, so if there is x plus 1, so you will get x plus 1 whole square. The definition is same according to this. Now here is x, so here is x, so here is x plus 1, so here in place of x you have x plus 1 minus 1. In other words, you can say that just replace, you see that this x is replaced by x plus 1, so replace these x in the right side by x plus 1. So you will get f of x is equal to, f of x plus 1 is equal to, according to a plus b whole square, a square plus b square plus 2ab. Now this is x plus 1 minus 1, plus 1 and minus 1 is cancelled, so f of x plus 1, this is x square. Now x and 2x, this is 3x and 1 square mean 1. So this is the required function having argument x plus 1. Part number 4. In part number 4 of question number 1, the given function is f of x is equal to x square plus x minus 1. In part 4, you need to calculate point f of x plus h minus f of x divided by h. Okay, so to calculate this, to find this, first of all, you clearly have the value of f of x. You didn't have the value of f of x plus h, so you just need to calculate first the value of f of x plus h. So as we know that as f of x is x square plus x minus 1, so replace x by x plus h to get f of x plus h. So you see that I am replacing this x by x plus h, this x will be replaced by x plus h whole square, this x will be replaced by x plus h minus 1. So this implies that f of x plus h is equal to x square plus h square plus 2hx, a plus b whole square. Here the value of a is x and the value of b is h, and that is x plus h minus 1. Now this implies that f of x plus h is equal to, I am writing it in the let's say x square, then I will write, let's say, you can also leave this here as it is, but if you can write it in the according to the power in descending order of the variable x, that must be in this fashion. So then, so this is your constant term, and this is a term which contain the power of the variable 2, and here is the power of 1 and 1. So you may say this is the descending order with respect to the variable. So now this is your, let's say this is 1, so this is your h f of x plus h. Now to calculate this, so f of x plus h minus f of x divided by h. So in place of f of x plus h, I am writing x square plus 2hx plus x plus h square minus plus h minus 1 minus f of x. So f of x is equal to x square plus x minus 1 divided by h. So you see that this is minus 1, and when this multiplied, this minus multiplied, so this will be plus 1. So these two are cancelled, this is minus x square and this is plus x, so these will be cancelled. This is plus x and this is minus x, these two will be cancelled because this minus multiplying with this whole function. So you will get 2hx plus h square plus h divided by h. So this is f of x plus h minus f of x divided by h. So taking common h from the numerator, because h is present in all the three terms. So when h is taken common, so here you will get 2x, this will be plus h, and this will be plus 1 divided by h. So h is cancelled with h. So this implies that f of x plus h minus f of x divided by h is equal to 2x plus h plus 1. So this is your h is a constant. So this is the required value of f of x plus h minus f of x divided by h. So this is part number 4 of question number 1. Okay, this is question number 1. Now moving towards the question number 2. In question number 2, the given function is, we have 4 functions are given in part number 2. The first function is f of x is equal to 7x minus 2. The second function is g of x, which is 2x divided by x square minus 4. The third function given in the question 2 is h of x, which is 4 times square root of 25 minus x square. And the last function is k of x in question 2 is x square plus 1. These are the 4 functions given in question 2. You clearly see that all these functions are dependent on x. So x is your independent variable. This is a linear function. In this you cannot say this is a linear quadratic, because in numerator you have a linear factor and denominator we have quadratic. So leave it. This is a square root function, this is a quadratic function. You know linear, quadratic and square root functions. Okay, now you need to calculate, in part number 1 you need to calculate f of 6, g of minus 1, h of 4, k of 1 by 2. So this is so simple. For f of 6, so replace this x by 6. So when you replace this argument by 6, so it means that you must replace the value of x by that number which you place in the argument on the right side expression. So if I place x in the argument of the function, you see that there is 6. So you must need to replace this x. Whenever you need to replace all the x with this 6. So there is 1 x, so that's why I replace with 6. So you will get, from here you will get 42 minus 2, so you will get 40. So this value is f of 6 is equal to 40. Now g of minus 1. So g of minus 1, you need to replace this x by minus 1. So 2 into minus 1, there will be minus 1 whole square minus 4. So you will get minus 2 divided by 1 minus 4. So minus 2 divided by minus 3. So minus and minus is cancelled, so you will get 2 by 3. So the value of g of minus 1 is 2 by 3. Similarly, when you calculate the value of h of 4, so this is your h of x. So replace x by 4. So you will get 4. This will be 25 minus 4 square. So 4, this 4 is as it is, but replace just this x by 4, because you put an argument 4, because you need to calculate h of 4. So this is 25 minus 16. So this is equal to 4 into 9. 9 means 3 square. 3 square is cancelled with square root. So 4 multiplied by 3, you will get 12. So this value is equal to 12. Actually, this 40 is the image of 6 under this function f. This 2 by 3 is the image of minus 1 under this function is g. 12 is the image of 4 under this function h. And now in 4 part, you need to calculate k of 1 by 2. So just replace this x by 1 by 2. So k 1 by 2. So this is the definition of the k of x. Replace x by 1 by 2 mean argument by 1 by 2 whole square plus 1. So this is 1 by 4 plus 1. I am taking the LCM. 4 is the LCM. So 1 plus 4. So 5 by 4. So this is 5 by 4. So this 5 by 4 is the image of the 1 by 2 under this function k. So this is the part number 1 of question number 2. Now part number 2 of question number 2. In part number 2 of question 2, you need to calculate f of x minus f of 2 minus x minus 2. So you have as we know that f of x in question 2 is 7x minus 2. So when you calculate f of x minus f of 2 divided by x minus 2, so this f of x is given. X minus 2 will be remain as it is, and you need to calculate f of minus 2. So just replace x by 2, so you will get f of minus 2, f of 2, sorry. So 7 multiplied by 2, so this is equal to 14 minus 2, so this is equal to 12. So f of 2 is equal to 12. So this is the value of f of x, this is the value of f of 2. So just put equation 1 and equation 2 in this required form. So f of x minus f of 2 divided by x minus 2 will be equal to, in place of the f of x you will put 7x minus 2, and in place of f of 2 you will put 12 minus as it is. In place of f of 2 you will put 12 divided by x minus 2. So 7x minus 14 minus 2 minus 12 and x minus 2. So taking common 7, so this is you can write 7 multiplied by x, 7 multiplied by 2 divided by x minus 2. So taking common this 7 multiplied by 2, 14. So here x will be remain, and here you will get 2 divided by x minus 2. So x minus 2 and x minus 2 is cancelled, you will get 7. So thus in part 2, f of x minus f of 2 divided by x minus 2 is equal to 7. So this is the second question of exercise 8.1. In coming video inshallah we will discuss the question 3 and onward. Thank you.